You just enter the width of the catchment and the total length of the drain required and get the section of the drain. So you need to enter the width of the catchment. For example, if it is 50 meters and the length of the drain as 1000 meters, then you get the section of the drain as 0.93 meter by 0.93 meter, which will be able to handle the storm water up to a length of the entered 1000 meters. This is one way to design the drain, that is to give the width of the catchment and the total length of the drain and get the section of the drain. And in second way, you can also give the section of the drain. For example, if it is 0.93 meters and if the height of the drain at 0.93 meters, then you get the length of the drain up to which it is able to handle the storm water without being overflowing. So 0.93 by 0.93 meter section will handle the storm up to a length of the drain of 1010 meters. So there are two ways in which you can design a drain or check a drain section for its capacity. But remember, this is a critical section and you need to increase the depth so that a sufficient freeboard is available. I've given a link to this article in the description of this video and in the first comment of this video. This is an article, and in this article you will get this embedded design sheet in which you can enter the value in it. Drain section is drawn automatically. So the length of the drain is shown here and the total width of the catchment is the drain plus the road plus the right side houses and the left side houses. It assumes that the left and the right side is the catchment area from which the drain collects the storm water. So the total width of the catchment is this side plus drain plus road and the right side. So in this example, the width of the catchment is 40 meter, which means that total width of the catchment is 40 meters and the total length of the drain is 500 meter. And you get a drain section of 0.66 meters by 0.66 meters. Or in other way, if you give the section at 0.66 meter by 0.66 meter, you will get the maximum length of the drain as 506 meters. So let's look into other factors also. This is for a typical case of a city of Birganj in Nepal. I've taken the parameters of that city. So this sheet uses a formula, the rational formula. The C is the runoff coefficient, which I have taken as 0.8. The value of C is fixed, and for concrete it is 0.7 to 0.95 and I have taken a value of 0.8. The rainfall intensity I have taken a 5-year return period from the IDF curve and I have assumed the time of concentration as 0.5 hours. So I got a IDF curve of Simra Birgan sector of Nepal. So I have taken a duration of 0.5 hour and a 5-year return period in that I've got by extrapolating as 75 mm per hour as rainfall intensity, and the slope of the channel I've kept as very minimum as 4 inch in 100 meters only, and the Mannings coefficient I have taken as 0.015, which is for concrete, that you can see from this table. You can also change the value of these as per your specific cases. So with this you get the drain section and you also get the length of the drain by giving the width of the drain and the depth of the drain. So in these two ways you can use this Excel sheet to design or to check the design or you can also use it as roughly so that you can know the rough estimation of the size of the section before calculating it further. You can also check other design as well.